We are continuing our worksheet packet for AP Review Topic 10. This is our series topic, and this is a modified worksheet only for 2020. 2020 is our year where we have limited topics in series, and so this worksheet packet was tailor-made just for 2020. Okay, we've already done some of these as part of the lesson, and now this video is covering the remaining problems in this packet so that you can check yourselves. Okay, so we are going to begin with the problem from 2016, number 6. None of these have calculator with them, so this is only part A from that year because this is the only part that has concepts that you are responsible for knowing for the AP exam. I know that I could have given you the whole thing because I know you guys have had this whole thing, but I want you to focus on, for right now, just focus on what's going to be on the AP exam. Okay? All right. So function f has a Taylor series about x equals 1. Now since it's about x equals 1, we're going to have a lot of the x minus 1 to the first, x minus 1 to the second, x minus 1 cubed, all of those. It converges to f of x for all x in the interval of convergence. That makes sense. It is known that f of 1 is 1 and f prime of 1 is negative 1/2, and the nth derivative of f at x equals 1 is given by this formula when n is bigger or equal to 2. Write the first 4 non-zero terms and the general term for the Taylor series. Okay? So if we were given a function for x, I would write f of x is equal to whatever function, and then I would find f at 1. But here they just give us all of those values. So f of 1 is 1. So my first term in the series will be 1. Okay, f prime of 1 is negative 1/2. So my second term in the series will have this negative 1/2 in it. It'll be negative 1/2 divided by 1 factorial, which is the same thing as multiplying by 1 over 1 factorial, times x minus 1 to the first. And that will be my second term, my second non-zero term. Now we need the next non-zero term, so I need the second derivative at 1. For the second derivative, I need to go and use this formula. The second derivative, n is 1, so I'm replacing all of the n's with a 1. Negative 1 to the second is 1. 2 minus 1 is 1 factorial. And I'm going to write it as 1 factorial because I don't want to lose the pattern. I need to write the general term, so I don't want to lose the pattern. So keep your factorials for right now. And then 2 to the second, right? 2 squared. So my next term will be positive 1 factorial over 2 squared. It's the second derivative term, so I need to divide by 2 factorial and then multiply by x minus 1 to the second. And that will be my third non-zero term. Now for the third derivative at 1, n is 3, negative 1 cubed is negative, 3 minus 1 is 2 factorial there, and then 2 cubed. So this next term will be negative 2 factorial divided by 2 cubed, divided by 3 factorial, and then x minus 1 cubed. I'm going to save. I'm not going to write the general term quite yet because I want to simplify, and then it'll make it easier to write that general term. All right, so let's simplify this. This is 1 minus, okay, what does this simplify to? Well, this just simplifies to 1 over 2. My question is, do I want to simplify it to 1 over 2? And do you see how these factorials are indeed going to reduce each time? 2 factorial over 3 factorial is just leaving a 3 on the bottom. 1 factorial divided by 2 factorial just leaves a 2 on the bottom. So yeah, I can just get rid of that and just write it as a 2 times a 1 here, right? And you could just write it as just a 2 on the bottom if you want to. I'm going to leave it 2 times 1 to just really make that stand out. Okay. Since there's not going to be anything else on top, I think I'm going to move my x minus 1 on top. Okay. You could even write this as 2 to the first if you wanted to really see that pattern, right? Plus, this will be x minus 1 squared over 2 squared times 2 minus x minus 1 cubed over 2 cubed times, again, those reduce to just a 3, plus dot dot dot. Okay, time for a general term. Okay, let's see. We've got, it is alternating in sign, so I'm going to alternate. So -1, if I start n at 0, this first term will be positive because -1 to the 0 is positive, so that works. Okay, then let's get our x minus 1s going. So we have x minus 1 to the, okay, the powers differ by just 1, starting at 0, right? So I can just put an n there. And then this 2 to the first, 2 to the second, 2 to the third. The first one would be 2 to the 0, so 2 to the n will work. And then we have the n's down here, the 1, 2, 3. So this is just going to be an n there. Now, is there a problem with that? Is there a problem with that? And some of you I know have caught this problem. Does this work for the very first term? Does it work for the very first term? These all work, but does this work for the very first term? When n is 0, do we get 1 down there, over there? And the answer is no. The answer is no. And I played with this, and I tried to change it. Maybe I need to start in at 1. Maybe I can, do I want to n plus 1 here, or something like that? And the answer is there's no way to change this to get that 1 right there. Okay? So I'm going to say that this is true if n is bigger or equal to 1. Then it is true. And that would give me all of these terms. And then I would say if n equals 0, the first term, that's our first term, is 1. Okay? Or you could just say the first term is 1. So this general term, it does work for the entire series except for the first term. So we could call this 1 plus that series, and that would work. Okay? I went and I looked up, I always go and look up how they scored it, right? What points would I have gotten and stuff. And their answer just gave this as it is. It did not qualify it in any way, all right? So this was their answer. So the general term does work. It is a general term. It just didn't work for that very, very first term, but you could still write the series as it is, the sum with n going from 1 to infinity, okay? And then just add 1 to it, all right? So that was that. The way they scored this was they gave 1 point for the first 2 terms. They gave 1 point for the third term. They gave 1 point for the fourth term. And they gave 1 point for the general term. So 4 points was a lot for that little problem, I thought. Okay? So clearly they think that it's kind of important. All right, let's take a look at what came next. Let's take a look at the problem from 2013 on your next page. Okay, this was number 6 again, and in this case I could give you both A and B, because both of those I think are things that you could be held responsible for this year, for 2020. Okay, a function f has derivatives of all orders at x equals 0. Well, that's good. X equals 0, we like that, little Maclaurin. Let p sub n of x denote the nth degree Taylor polynomial for f about x equals 0. It is known that f of 0 is -4, and that the first degree Taylor polynomial, when x is a half, is -3. Show that f prime of 0 is 2. Okay, well, I would like to, since they talk about this p sub 1, I would like to go and find p sub 1, and then I'm going to put a half in for x. So let's first find p sub 1 of x. That will be the first degree Taylor polynomial. Well, the first degree Taylor polynomial will be f of 0. It'll be f of 0 plus f prime of 0 divided by 1 factorial times x minus 0 to the first, right? That's the first degree Taylor polynomial. That's what it is. Now they're saying that if I replace the x with a half, this thing will equal -3. And we know that f of 0 is -4. So I think I will go ahead and put -4 in for f of 0. Like that. And now I'm going to replace the x with a half. I'm replacing x with a half. I don't know what that first derivative is. 1 factorial, though, is 1, right? So that's times a half. And that must equal -3. That must equal -3. And now all of a sudden it fell into place. I know what I'm going to do. Just solve this for f prime. So I'm going to add 4 to both sides and then multiply by 2, right? Add 4 to both sides. 4 plus -3 is 1, and then multiply by 2, and I get f prime at 0 must be 2, which is what I was trying to show. QED. That's what I was trying to show. This was worth 2 points. 1 point for uses that first degree Taylor polynomial, and then 1 point for verifies, f prime of 0 is 2. Okay. Part B. It is known that f double prime of 0 is -2/3, and f triple prime of 0 is 1/3. Find the third degree Taylor polynomial. Well, now that we have the first derivative, we have the second derivative, the third derivative, we have the function value at 0, we can easily write that third degree Taylor polynomial. So the third degree Taylor starts off with this -4, f of 0, and then we need the first derivative at 0, which is 2, over 1 factorial times x to the first, right? Plus -2/3 divided by 2 factorial x squared plus 1/3 divided by 3 factorial x cubed, and that is the third degree Taylor. And we can totally say stop there. We don't have to simplify. This was worth 3 points. 1 point for the first 2 terms, 1 point for the third term, 1 point for the fourth term. Okay? And that was from 2013. Now let's take a look at Part A from 2019. Part A from 2019. A function f has derivatives of all orders for all real numbers x. A portion of the graph of f is shown, along with a line tangent to the graph of f at x equals 0. So it's clear to me that this curve must be f, and this is the line tangent to f at x equals 0. Okay? Selected derivatives of f at x equals 0 are given in the table. So here are some derivatives over here. Write the third degree Taylor polynomial for f about x equals 0. Okay? All the information is there. Let's see what we have. We need f at 0. Do we have f at 0? Well, we sure do, because they gave us a graph, and f of 0 is 3. F of 0 is 3. Do we have f prime at 0? Well, the table begins with the second derivative. Do we have f prime at 0? Well, yeah, we have the tangent line here. Can we find the slope of that tangent line at 0? Sure we can. All we have to do is count here. I'm finding 2 points that lie right on the corners here, and these 2 points do. And this goes down 1, 2, 3, 4, and to the left, to the right 2. So that's down 4 over 2. So f prime of 0 is -2. F double prime of 0 I can go grab from the table. F double prime of 0 is 3. F triple prime of 0 is -23 over 2. Okay? So for part A, we're not going to use that fourth derivative because we're only going up to the third degree Taylor. Okay? So the third degree Taylor, I can name it. If I want to name it, I can name it, but you don't have to name it because it's not a child, right? So, but I'm going to name it. Anyway, okay, starts with the f of 0, so that's 3. Then we go to the second derivative, so -2 divided by 1 factorial. We're going about x equals 0, so it's just x to the first. And then plus 3 divided by 2 factorial, because we're on the second degree term, x squared, minus 23 over 2 divided by 3 factorial, x to the third. And that is the third degree Taylor, so stop there. This was worth that year 1 point for any 2 terms, and then 1 point for the remaining terms. So total of 2 points for that. Okay, so for the rest of these problems, these originally on my worksheet were multiple choice questions, and I just made them, I removed them, some of the multiple choice choices when I could. Okay, so these are just intended to get you thinking about the series, our tests, and so forth. Okay, the graph of the function represented by this Maclaurin series intersects the graph of y equals x cubed at x equals what? Okay, this is a calculator question. So the graph of this intersects the graph of this at what value of x? Well, the graph of this looks a lot like e to the x, right? Because of the 1 factorial, 2 factorial, 3 factorial. Only it's not exactly e because I have these negatives, right? So the way I would think of this is like this. I'm going to write the series for e to the x. This is the series for e to the x. Okay? And now I want to get this, so I see that, you know, every other one is alternating. So if I replace x with negative x, that's going to work for me. So e to the negative x replace every x with negative x. Negative x squared is still x squared. Negative x cubed is negative x cubed. I get exactly what I have there. So this is the graph, this is the function for e to the negative x. So I just need to see where this graph intersects that graph. And I have a calculator to do that with. So grab your calculator and y equals, clear out what's there. All right, e to the negative x and x cubed. Just see where they intersect. I'm just going to do zoom 4, see where they intersect. There's e to the negative x. Here's e to the x. Where do they intersect? Second calc 5. Oops, second calc 5. Enter, enter, enter. 0.773. So I'll say y equals e to the negative x intersects y equals x cubed at x equals 0.773. Okay? Number 3, the coefficient of x cubed in the Taylor series for e to the 2x. Well, e to the x is this series. So e to the 2x, I'm going to replace every x with 2x. Every x I'm replacing with 2x. 2x squared over 2 factorial. 2x cubed over 3 factorial. I want the coefficient for x cubed. The coefficient for x cubed will be 2 cubed over 3 factorial. 2 cubed over 3 factorial. Or 8 over 6, which would be 4 over 3. Okay? Number 5, find the sum of this series. Well, to find the sum, to actually find the sum, we know it either has to be e to the x, cosine x, or sine x, or geometric or telescoping. Those are the only ones that we can find the sum of. This is clearly not one of our Taylors because I don't see any factorials. So this has to be geometric. Has to be able to find the sum. So it's geometric. Let's find r. To find r, you can take any term and divide by the term in front of it. Any term divided by the term in front of it. I'm going to choose this term, negative 1/3, and I'm going to divide by the term in front of it. If I multiply top and bottom by 6, I get negative 2 over 3, right? So that is my r value. The first term, is 9 over 8. So the sum is a over 1 minus r. That would be a safe stop. If we had to, if it was multiple choice, which it won't be for your AP exam, I would multiply by 24 over 24, and I would get 27 over 24 plus 16, which is 27 over 40. Okay? When this was a multiple choice question, that was the answer. All right, which of the following series diverge? This is just a little practice on remembering what your convergence and divergence tests. This series is a P series. The 8 does not matter at all. There's no n involved. It doesn't matter. You could pull it outside, change it to a 1. Okay? So this is a P series where P is 0.997. That is less than 1. Therefore, this series diverges. This is also a P series. P is equal to 3 over 2, because that square root is a 1/2 power, right? So 3 over 2, which is bigger than 1, so this series converges by P series test. This is the harmonic series, which diverges. Okay, again, the 5 doesn't matter. Take it out. So diverging harmonic. So which diverge? 1 and 3 diverge. Next up, number 8 says let f be the function given by this equation, this function. Let p of x be the third degree Taylor polynomial. Third degree, just 3. Find the third degree Taylor polynomial, but call it p of x. Okay? So we start with we have f of x is equal to this function. So we can find f of 0. We want to put 0 in for x. Putting 0 in for x, cosine of 3 pi over 4 is negative square root of 2 over 2. Now we go to the first derivative. The first derivative of cosine is negative sine, so negative. The derivative of the inside, little chain rule, 3 sine of that same argument. So f prime at 0, plug in 0 for x, I'll have negative 3 times sine of 3 pi over 4 is square root of 2 over 2. Second derivative. Derivative of negative sine is negative cosine. This is going to be, the derivative of the inside is 3 times that 3 that's out there. Cosine 3, same argument. Now plug in 0 for x. This is double prime. 0 for x, so we'll have negative 9 times cosine of that would be a negative square root of 2 over 2. So that will be a positive 9 square root of 2 over 2. Third derivative. Derivative of negative cosine is positive sine. And then that'll be a 27. Keep your argument. Plug in 0. 27. Sine of 3 pi over 4 is square root of 2 over 2. And we've got it. Okay? So p of x, the third degree Taylor, will be, we start with our constant, and that's just our first term. For the second term, we use the first derivative, negative 3 square root of 2 over 2, divided by 1 factorial, times x minus 0 to the first. Go to your second derivative term, plus 9 square root of 2 over 2, divide by 2 factorial, x squared. Go to your third derivative term, plus 27 square root of 2 over 2, times 3 factorial, x cubed. And that is the third degree Taylor polynomial. Okay? Number 9. The Maclaurin series for the function f is given by this. What is the value of f of 3? So we're replacing x with 3. We're replacing x with 3. So f of 3 will be the series for negative 3 to the fourth. I'm sorry, negative 3/4 to the n. That is geometric. R is negative 3/4. The very first term, if you put 0 in for n, negative 3/4 to the 0 is 1. So this sum will be a over 1 minus r. Save stop. Okay. Which of the following series converge? Converge. In this series, I see Big Mama, and factorial is in the bottom, right? So she's going to make this whole thing converge. Factorial in the bottom, this is going to converge. If you needed a test for that, the ratio test is good. Also the root test, but those two tests would work well for that. In number 2, I see Big Mama again, and she's up on top this time. Well, she's heavy on top, so she's going to make this thing diverge. It would diverge by nth term test. It would also diverge by ratio test, also by root test. Okay. All right, so for this one, I need to use a little comparison test. So n over n cubed. That behaves like n over n cubed. That's what it behaves like. So we're going to compare this with 1 over n squared, which is a converging p-series. Converging p-series. So this thing converges. So 1 and 3 again converge. Number 10, for what values of p will both of these series converge? Both of these converge. Well, let's take a look at this one. For this one, this converges. It's a p-series, and we know that the exponent needs to be bigger than 1 to converge. It converges if 2p is bigger than 1, which means p has to be bigger than 1/2. For the other series, we're looking at a geometric series, and the geometric series converges if the absolute value of p over 2 is less than 1, right? Is less than 1. So this says that the absolute value of p is less than 2, right? By the way, for a p-series, p has to be positive here, right? If p was negative, it would send this to the top and then it would diverge. So p has to be positive. Okay, well, p is greater than 1/2, so it has to be positive anyway. So p here is greater than 1/2, but also p is greater than 1/2, but p is also less than 2, right? So p is greater than 1/2, but less than 2. Okay. Number 11. Let f be a function having derivatives of all orders, and here they give us several derivatives. What is the third degree Taylor polynomial? Okay, about x equals 3. So the third degree Taylor, we'll start with our function value, go to our first derivative. So negative 1 over 1 factorial times x minus 3 to the first. Don't forget all your x minus 3's because your center value is 3. Now we go to our second derivative, 6, 2 factorial, x minus 3 squared, and then lastly 12 over 3 factorial, x minus 3 cubed, and we can stop there. That's the third degree Taylor polynomial. Okay, which of the following series converges for all real numbers x? Okay, for all real numbers x. So if I put a 5 in for x, I'd have 5 to the n over n. Does that converge? No, that diverges because 5 to the n is heavier. As n goes to infinity, that is going to rule, right? So this diverges. For the same reason this diverges. For the same reason this diverges, that x to the n is going to rule, right? Oh, then I see this, and I see this factorial in the bottom. That's going to rule over any kind of exponential, right? So this, here's my converging. Here the factorial is up on top, so that will diverge. So D is the only converging series there. Okay, on to number 13 here. What is the sum of this series? Well, again, we're limited in the types of series that we can actually find the sum of, so we're looking for factorials, and I see these factorials. I see a 1 factorial, 0 factorial, 2 factorial. So this is e again. So e to the, I write the series for e to the x. And then this is that series if x is ln of 2, right? So I'm replacing x with ln of 2. So replace x with ln of 2. And that is that series, right? So this series has a sum of e to the ln of 2, which is the same thing as 2. Okay? All right, what is the value of this series? Well, this is a geometric series. R is 2/3. A, the very first term, is what we get when we put 1 in for n. So when we put 1 in for n, we have 2 squared, which is 4, over 3 to the first, which is 3. So the sum is a over 1 minus r. FRQ, safe stop. Okay, number 16 down here. Find the sum of this series. Another geometric series. R is negative 3 over 4, right? A is put 1 in for n, so A is going to be negative 3 over 16. So the sum is A over 1 minus r. Okay, number 17. If this series converges by ratio test, then which of the following is true about this series, which is the same thing except we have n times a sub n. So first of all, let me say, what does this mean? For this to converge by ratio test, that means that the limit as n approaches infinity of the ratio of a sub n to a sub n plus 1 to a sub n, the absolute value, must be less than 1. That's what that means. So what's true about this one? Well, let's take this one. Well, for this to converge by ratio test, the limit as n approaches infinity of n plus 1, a sub n plus 1, divided by n a sub n, that would have to be less than 1. So the question is it? Is that less than 1? Well, a limit of a product is the same as a product of the limits, right? So we can split that up into this. Right? This one, we already know what this one does. This is less than 1. We know that from the given. This is 1, right? As n goes to infinity, the plus 1 doesn't matter, and then we reduce to 1. So this whole thing is less than 1, which means it converges by ratio test. So yes, that's true. So A is the answer there. Number 18. Consider this series. If the ratio test is applied, which of the following inequalities results, implying that the series converges? So we want to go ahead and start the ratio test here. So for the ratio test, we start with that, right? We start with the n plus 1 term, n plus 1 over n plus 1, divided by the nth term, which is the same thing as multiplying by the reciprocal of the nth term. There's a buzz in the background here. Anyway, so let's reduce this. And by the way, n is going to infinity, so this entire expression is positive, right? So I can lose these absolute values. That's why none of these choices have absolute values in them. Okay, so this is the limit as n goes to infinity of the e to the n's reduce to just e on top, right? Subtract the exponents. And then the factorials reduce to just an n plus 1 on the bottom. This limit is equal to 0, right? As n goes to infinity, this goes to 0. So this is equal to 0, which is less than 1. So which of these is that one? It will be this. So D. Okay. What is the sum of this series? Okay, I'm looking at the denominators and I see the even factorials, so I know I'm dealing with a cosine. So I write the series for cosine, which begins with 1, alternates in sign, and then I have all of the even. Okay? And now I need to put, in place of the x, I need to put a 2, right? In place of the x, I need a 2. So this is just cosine of 2. Number 20. Here is a 5th degree Taylor polynomial. What is the value of f, the third derivative of f at 0? Okay, the third derivative of f. Well, the third derivative is associated with this x cubed term, right? And any x cubed term for a 5th degree Taylor polynomial will be the third derivative divided by 3 factorial x cubed, right? That would be for any x cubed term centered at 0 for a Taylor polynomial. Well, we know that this is equal to negative 10x cubed, so the coefficients have to be equal. So I'm going to set those coefficients equal. So the third derivative at 0 must be negative 10 times 3 factorial, which is negative 60. Okay. Determine if each series converges or diverges. Tell which test you use. State the conditions. Okay? All right. This is a geometric series. R is equal to negative 2/5. The test, the conditions of this test deal with the absolute value of R. The absolute value of R here is less than 1. Therefore, this series converges by geometric series test. Okay? 23. This is a P series. A P series with P is equal to, okay, this is n to the first times n to the 2/3, right? So P is equal to 1 plus 2/3, or 5/3. That's bigger than 1. Therefore, this series converges by P series test. Next up, number 24. I see that this series is alternating, so I'm going to use the alternating series test. Okay, alternating series test. 3 little steps. Is it alternating? Goodness, let me spell that right. Is it alternating? Yes, it is. Number 2, is the limit, as n goes to infinity, of the absolute value of this, is that 0? Yes, it is. Is the magnitude of terms decreasing? Is the magnitude decreasing? It is decreasing. If you wanted to show that, we want the n plus 1 term. We need the n plus 1 term to be less than the nth term. Is it? Yes, it is. So it's decreasing. Therefore, this series converges by alternating series test. If you're writing an FRQ, you write out your words, okay? Write them all out. Try to spell them right. Okay? Number 25. Well, I know this thing is going to converge. I know it converges because Big Mama's down in the bottom. we can use the ratio test to show that. Okay, so I'm going to set up the ratio test. The n plus 1 term divided by the nth term. So I'm going to flip and multiply that nth term. And that is equal to, okay, the 5's reduce and it leaves a 5 on top. The factorials reduce and it leaves an n plus 1 on the bottom. Now let n go to infinity. This whole thing will go to 0, which is less than 1. So this series converges by ratio test. Write the first step in the ratio test for determining the convergence or divergence of this thing. Okay? So just write the first step. Okay, we can do that. Limit n goes to infinity of the absolute value of, so I want to replace n with n plus 1. Replace n with n plus 1. Then we're going to divide by the nth term, which is the same thing as multiplying by the reciprocal of the nth term. And that is the first step. That's the setup. Okay? What is the sum of the series? Well, it's not one of our Taylor series because I don't see any factorials down here. It's not one of our known Taylor series. So it must be geometric if we can find the sum. Okay? So if it's geometric, what is R? Well, what do you multiply this by to get to the next term? It needs to be negative, and you're multiplying by 1 on top. What are you multiplying by on the bottom? 3e. The first term is 2 pi over 3e, so the sum will be a over 1 minus r. Save, stop. 29, which of the following series converges? Which of the following series converge, I mean? Okay. For 1 here, it's alternating, but is the limit 0? The limit is not 0 because this 3 to the n is more powerful than n to the 5, right? So yes, it's alternating, but it's not decreasing in magnitude and going to 0. So therefore, this series diverges by nth term test. Okay? Over here, another alternating. This is also alternating. Is it decreasing in magnitude to 0? Yes, it is. So this converges by alternating series test. Over here, this is just a harmonic. And a harmonic, it's not alternating, right? So this is the diverging harmonic. So the only one that converges here is 2. Okay. Just a few more. Okay. This, they say, is a convergent series for which values of p? Well, this is just a little p series. It converges when 5p minus 2 is bigger than 1, right? So 5p must be bigger than 3. So p must be bigger than 3/5. That's it. Number 31. Given that this is a geometric series where all of the terms are positive, the first term is 72, the third term is 8, which of the following statements about the series is true? And I see that they're finding the sum of these. Okay? So can we find the sum of these? So let's find R and see if we can find the sum of them or if it diverges. Okay? If this geometric series converges, we would be able to find the sum. So this is definitely not the answer here. All right. So the first term is 72. The third term is 8, right? And then it would keep on going. Well, to get to the next term from 72, we would multiply by r. So this next term must be 72r. To get from 72r to 8, we would multiply by r again, right? So 72r squared must be 8. So r squared must be 1/9, and r, it would be plus or minus 1/3, the square root of 1/9, right? But since all the terms are positive, r has to be 1/3, since all terms are positive. So the first term is 72, r is 1/3. Since the absolute value of r is less than 1, we know this thing converges. So it's not a diverging series. So the sum will be a over 1 minus 1/3. Multiply top and bottom by 3 here. 6, 21, 3 minus 1. So 216 divided by 2 will be 108b. Okay, just a couple more here. Which of the following statements are true about this series where a sub n is this? Okay, is the series alternating? Is this series alternating? Yeah, it is. So definitely 1, but all the choices have 1 in them, so that didn't help. Number 2, this means that the series is decreasing. Is this series decreasing? Is the series decreasing? Well, in magnitude. Is the series decreasing in magnitude? No, it's not. N squared is more powerful than ln of n, right? So no, this series is not decreasing. Is the limit 0? Nope. For the same reason I just talked about, it's not 0. So only 1. Which of the following converges? Again, this is a p series with p is equal to 1 plus a half, which is bigger than 1, so this converges. This one has factorial on the bottom, so this converges by ratio test. This is geometric. R is pi over e. Is that bigger than 1 or less than 1? Well, it's bigger than 1 because pi is bigger than e, so this one diverges. So 1 and 2 only. What makes an alternating series converge? Alternating in sign, decreasing in magnitude to 0, which means the limit as n goes to infinity is 0. Can a series diverge by the alternating series test? No. If this is not true, it diverges, but it diverges by nth term test, right? What is the harmonic series? The harmonic series is a p series with p equal to 1. That's a harmonic series. Okay? All right. Hopefully that made sense to you. If not, come and ask me questions.